Physics of Music. Part 1. Resonance. Resonance. What is resonance? When one object vibrates at the same natural frequency of the second object, that forces the second object into vibrational motion. The word resonance comes from the Latin root resound, which means to sound out together with a loud sound. Resonance is a common cause of sound production in musical instruments, and the result of it is always a big vibration, which results in a loud sound. A resonance model. This resonance tube models the resonance in musical instruments. So how it's done is partially filled with water and forced into vibration with a tuning fork. The tuning fork is the object that forces the air inside of the tube into resonance or vibration. So as the tuning fork vibrates at its own natural frequency, they create sound waves that affect upon the opening of the tube. And these sound waves produced by the tuning forks tuning fork forces the air inside of the tube to vibrate at the same frequency. So at this point, when our first object, which is the tuning fork, vibrates at the natural frequency at the second object, which is the air inside of the tube, the resonance is observed and occurred. So in the absence of resonance, what happens in the absence of resonance? If you have no resonance, the sound of the vibrations is not loud enough to be heard or to be recognized. So, for example, the frequency at one object, which here is our tuning fork, is not identical to the natural frequency of the second object, which is our air column inside of this resonance tube. The resonance will not occur. Thus, the two objects will not sound out together with a loud sound. So, yeah, but the location of the water can be altered. Remember, this is an experiment. So, increasing or decreasing the water inside can increase or decrease the length of the air column inside. Recall that an increase in the length of vibrational system, which is our air tube here, increases the wavelength and decreases the natural frequency, and vice versa. A decrease in length of vibrational system decreases the wavelength and increases the natural frequency. So by raising and lowering the level of the water here, the natural frequency of the air in the tube can be matched to the frequency at which the tuning fork vibrates. And once the match is achieved, the tuning fork forces the air column inside of this tube to vibrate also at its natural frequency. Thus, a loud sound is formed and resonance is achieved.